right, so we're looking at probabilities, and hopefully you are learning that you don't want to gamble, right? Okay, so it says a couple plans on having 9 children, so a total of 9 children. What is the probability that there will be at least one girl? And we're assuming the probability of a boy and the probability that they get a girl are equally likely, meaning 1/2. All right, and then it says, is that probability high enough to be very confident that they will get at least one girl? Well, this is one of these that you probably don't want to do the how many different ways with 9 children. Okay, can you get at least one girl? Because the first one could be a girl, the second one could be a girl. So there's a nice little word called the complement. And what the complement is 1 minus the probability of what you want. So in other words, it would be a lot easier to say 1 minus the probability they got no girls, instead of the probability of at least one girl. And so with this complement here, then, as we know, the probability is 1/2 and out of 9. And if you multiply that, meaning 2 to the 9th power, well, 1 to the 9th power is 9, and you'll get 5/12. And going back to your fraction days, getting common denominators, because it wants the answer as a fraction, then you will get your answer. All right, so this complement is something really cool to know about, because think about it if it was like 1 out of 100 children, right? And it's just a lot easier and faster, especially if the probabilities aren't the same. All right, so let's look at another one. This one here says, find the probabilities of a couple having a baby girl when their 6th child is born, given, so this is saying, what's the probability the 6th is a girl, given that the first 5 were all girls. Well, what this is trying to get you to recognize is that these are independent events. So it doesn't matter if they had girl, 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 girl. It doesn't matter at all. The probability is still going to be 1/2. Oh, that reminds me on this last one. Wait. Notice here it says, is the probability high enough to be very confident that we'll get at least one girl and 9 children? Oh, well, yeah. I mean, that's very confident, right? Okay, so in other words here, the probability that the 6th child is a girl given the others were girls, because these are independent events, have nothing to do with each other, so it's still 1/2. And is the result the same as the probability of getting all girls? Well, no, that's a little different, right? Because that's saying the probability the first one's a girl, probability the second one's a girl, and so on. All right, in a certain country, the true probability of a baby being a girl is 0.489 among the next 8. So now we're looking at sampling 8. What is the probability that at least one of them is a boy? So once again, the probability at least one boy, so this is like that other one, would equal 1 minus the probability no boys. Okay, and so in this case, what is our 0.489, and we want 8 chillins. So if you throw that in your calculator, you should get that value. So once again, using the complement, very, very helpful. All right, the data represents the results of a test for a certain disease. Assume one individual in the group is randomly selected. Find the probability, so the probability of getting someone who tests positive, so they test positive given they have the disease. Now, what I do with tables, because tables are actually very important, is typically whenever you're doing reading, studying, you're going to see a lot of information given in tables, is I remember the formula. So they test positive and they have the disease, all over the probability they have the disease, okay? Or in other words, in this case, the number of ways. And so here I look for this intersection, okay? Because that's how many tested positive and how many have the disease, and then how many total actually had the disease, 123 plus 9. And this one wants your answer as a decimal. Okay, so you could write these true probabilities, 123 out of the total divided by 132 out of the total, but notice the totals are going to cancel anyway. But this is how I always remember how to read a table, is the intersection, okay, or the intersection of the two values, and then we call this the joint probability. Typically are going to be these totals here, okay? I'm sorry, this is the marginal probabilities, okay? And because they're in the margins. And so if you get this formula down, it's pretty easy to read tables just based on, do you care about an intersection and they're positive and they have the disease, versus here, my marginal probability in the margin, the probability they just have the disease. All right, a classic counting problem is to determine the number of different ways the letters of misspell can be arranged. So the first thing I notice is I write out MISSPELL. So I see there's just one M, one I, there's two S's, one P, one E, and two L's. So, and then I count MISSPELL. So there's a total of 8 letters. And you don't really have to write each one of these down, but just to because you know 1 factorial is just 1, but just to show it. So there's the M, the I, the S, the P, the E, and then the L. Okay, and remember, factorials mean 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Hopefully you have found that factorial button in your calculator. And then of course all the ones are just 1, so 2 times 1 and then 2 times 1. Okay, so I could cancel out the 2's, I could cancel that out, and when I multiply these I get 10080. So that would be the number of ways. All right, if let's play the lottery. Let's do it, right? So if I want to play the lottery, what's the probability? There's a pick 6, I guess they call this. I never play the lottery because you know why? I understand probabilities. All right, so let's look here. Basically what this is a total of 33 numbers taken 6 at a time. So do you recognize this formula? Combinations. Okay, so this typically you'll see something that looks like that, where in this case would be 33 combinations taken 6 at a time. And you could multiply all this junk out, 33, 32, 31, 30, 29, 28, 27. I stopped there because I know that's going to be 27 factorial. And then of course 6 times 5 times 4 times 3 times 2 times 1. And you can do some canceling, right? You can cancel that. You could cancel that. 3, you could cancel that. 2, you could cancel that, and then multiply. But this is really where you want to learn your calculator, to be able to use the calculator to find, and you should get this value for the combinations. Well, remember that it's asking you, let me put my commas in the right place, that's a 0. It's asking you for a probability where there's only one way for this to happen. So why do people play the lottery? I know somebody's got to win, right? All right, so have fun with the probabilities and let me know if you have any questions or need to see anything else worked out.